Hello girls, we're going on to the next section in science, which is 4.2.5, efficiency and friction. So as we continue talking about motion and how things move and how they most efficiently move, we're going to talk a little bit about the role that friction plays in that. And so we're on page 245 in your science book. Efficiency and friction. Objectives for this chapter. Evaluate the efficiency of a machine. Identify factors that contribute to friction. Distinguish between ideal and actual mechanical advantage. We talked about mechanical advantage last time. Vocabulary, efficiency. A measure of the amount of useful work done by the machine compared with the amount of work done to make the machine operate. Okay? Suppose you and your classmates have chosen to give gifts to the children at a local shelter. You have 100 shoeboxes to fill and only 2 hours to get the job done. How will you set up all the items to go into the boxes? Our schools have had experience with this. What order should the gifts be placed in each box? Should each person be responsible for one box, or should one person be responsible for one thing that goes in every box? All these questions have to do with efficiency. Someone who gets a lot of work done in a small amount of time is efficient. Machines also have efficiency. The efficiency of a machine measures the amount of useful work done by the machine, which is work output, compared to the amount of work that is done to make the machine operate, work input. So basically, how hard is the machine working and how much is it producing? Those are kind of the two things that are compared. When your class becomes a human machine, assembling 100 gift boxes, as much as the work input as possible should go into making the gifts and not into moving things around and walking from one pile to another. Think about lifting a 20 kilogram box 1.5 meters into the back of a truck. The resistance force is about 200 newtons, which is 9.8 meters per second squared times the 20 kilograms. The work output can be calculated by multiplying the resistance force times the distance, 200 newtons times 1.5 meters. In this example, the work output is 300 joules. So for formula, work output equals resistant force times the distance. Calculating the work input requires knowing how much work is accomplished by a machine. Suppose you push the same box with 40 newtons of effort forced up a 10-meter ramp to a truck. The work input would then be calculated by multiplying the effort force, 40 newtons, by the length of the ramp, 10 meters. The work input equals 400 joules. So work input equals the effort force times the distance. The efficiency of a machine, the ramp, is then calculated as the ratio of work output to the work input and expressed as a percentage. So efficiency equals work output divided by work input times 100. The ramp's efficiency equals 75%, or 300 joules over 400 joules times 100%. What does this mean? It means that 75% of the work put into moving the box actually went into moving the box. The work, 400 joules, that you had to do to get the box up the ramp was actually more than the required to lift the box straight up, which was 300 joules. Even though the amount of work increased, it was easier for you to do the work because only 40 newtons of force had to be exerted instead of 200 newtons. And so what they're saying is, in this case, what's more efficient, to just pick the box up and put it in the truck or to push it up a ramp? And so pushing it up a ramp actually took more energy to do it, but it was easier for the person to push it up than it would be to pick it up and put it on the truck, even though it took a little bit more effort because of the gradual incline and because you're using a machine with it as well to help you get it into the truck. It does become easier and more efficient. Even though it's using more energy, it doesn't feel like it. No machine is 100% efficient. Forces cause some of the energy to be converted into waste forms. For example, in moving the box up the ramp, some of the energy is converted into heat instead of kinetic energy. Friction converts kinetic energy into heat because it resists motion in two objects that are moving against each other, and it is the biggest factor contributing to the inefficiency of machines. Increased friction converts even more of the kinetic energy of the moving object to heat. And in mechanical systems, heat is usually considered a waste of energy. So if you have, I'll draw it over here. If you have a ramp, here's our ramp, and you're pushing a box up that ramp, you are going to have friction, and friction is that right here, you have two forces moving against each other. You have the weight of the box pushing down, the force of the ram pushing up, and it causes this friction, which when you push it, friction, if you rub your hands together really fast, friction, the rubbing of your hands against each other is friction, and it causes what? Heat. Sometimes static electricity too. You can touch a balloon and it'll stick to you, or if you rub a balloon on your head, it'll cause static electricity and it'll get warmer. That's because friction causes energy to be wasted, but it can also cause energy in the form of heat. So as you're pushing a box up a ramp, it does create friction. It does create a small amount of heat energy. If you were to do that for long enough, it could catch fire. If you have two sticks and you rub them together for a long enough period of time, the friction between those two sticks causes heat, and because the wood you're using is dry, if it heats it up just at the right temperature, it can actually catch it on fire. You learn that in survival skills of how to start a fire in the wilderness without having matches. You can do so by causing friction, by rubbing things together to create heat, which then creates flame. All right. Let's see. Friction converts kinetic energy into heat because it resists motion in the two objects that are moving against each other, and it is the biggest factor contributing to the inefficiency of machines. Increased friction converts even more of the kinetic energy of the moving object into heat. And in mechanical systems, heat is usually considered a waste of energy. You actually don't want machines to heat up because they could overheat, you could blow and burn through the motor, you could cause it to short circuit. And so one of the things that we'll probably read about is machines usually have to have a lubricant of some kind. Oil, it's usually oil, something that will reduce the friction. It's like putting lotion on your hands. So it lubricates it. It makes it so that the metal and the machine isn't rubbing up against each other and causing friction, which causes heat, which can be dangerous. It can cause things to combust. It could catch on fire. And so they have to make the machines more efficient by having oil or lubricant in order for them to run without catching fire. Two things cause friction: the attraction of molecules on two surfaces that are in contact with each other, and the physical interlocking of irregularities of two surfaces. The surface of ice is very smooth, with few irregularities. People slip on ice because ice has little friction. Okay, if you think of the greasy pole too, if you go down to Fiesta, that's covered in grease, which causes very little friction. And so as you run across it, you just slide right off. It's not causing that friction that kind of helps stick you to it or keep you from falling off. You just slide right off. The amount of friction that occurs with two surfaces rubbed together depends on several factors. First, it depends on the characteristics of the surfaces themselves, whether they are rough or smooth, soft or hard, slippery or sticky. Second, it depends on how much force is pushed on the surface together. Objects with more mass naturally provide a greater force as gravity pushes the mass down. You can increase the friction of a piece of sandpaper on wood if you press down harder on it. Heavy vehicles and deep treads on tires add the necessary friction to get through slippery snow. So your parents might have snow tires that they put on in the wintertime, or you might have heard of them before. And what that does is they usually have deeper grooves in them. They might have spikes on them that cause grip onto the ground. But having deeper grooves in your tires makes the surface area less smooth of your tire, which allows there to be more friction as the tire rolls in the snow or rolls in the ice. It picks up little pieces, which causes the surface to not be flat anymore. It causes it to be rigid, which does create a sense of friction, which allows the car to be less slippery on the road. Ideal mechanical advantage assumes that no friction is working against the operation of a machine. In reality, however, friction is always at work. So the mechanical advantage of a real working machine must take friction and other forces into account. The actual mechanical advantage, AMA, includes friction and any other forces working against the efficiency operation of the machine. The efficiency of the machine measures how much friction reduces the ideal mechanical advantage. The actual mechanical advantage can be calculated by multiplying efficiency times the ideal mechanical advantage, I times M times A. So this is a lot of formulas, but this is one you can go back to your book and look them up, which formula is used specifically for which when you're answering your questions. I'm just going to go back to the for your information on the page before, the yellow box. Hovercrafts. Have you ever seen a hovercraft before? They're pretty cool. Would you take a boat to travel across land? Would you try to drive a car over a lake? Are these questions a little absurd? Of course they are. Boats and cars are designed to move over specific surface. Car tires provide just enough friction to put against the road and propel the car forward. A hovercraft can do both. This air cushion created by a hovercraft reduces so much friction that it can skim across land and water. Fans on the back of the hovercraft or air cushion vehicles force air beneath the vehicle to create almost frictionless environment and then force the air behind the vehicle, creating a thrust. How does a hovercraft stop? What will its purpose? What is the purpose of the skirt? So if you look over on the side, you have what a hovercraft looks like. You have number 1 are the propellers. Number 2 are air currents. Number 3 are fans. And number 4 is flexible skirts around the bottom of the boat. And so if you've ever seen a hovercraft before, I know they have hoverboards too now, like skateboards that hover. So basically what it does is it's forcing air down, which at a greater pressure than the weight or the mass of the boat. And so it elevates the boat, so it's hovering, or it looks like it's kind of floating above the surface, but it allows it to travel both over water and over land. And then it said that the energy that it has in the back, it transfers all that energy to the back, which creates a thrust or a rapid forward movement. And so that's how the hovercraft moves. All right, questions for today. All right, so in the lesson review, number 1, what is efficiency? So go ahead and define that word. If you can't find it back in the chapter, look in the glossary in the back of your book. Number 2, what is the efficiency? Excuse me. What is the efficiency of a machine with a work input of 375 joules and a work output of 125 joules? So if we're looking for the efficiency of a machine, we're going to go back and we're going to look at what did that formula look like. So back on page 245, if you're looking for the efficiency of a machine, efficiency was work output divided by work input times 100. Move this forward a little bit. Okay, so if we use the information that we've got, they gave us the work input is 375 joules divided by the work output, which is 125 joules. Okay, so this is efficiency equals We're going to do what's in the parentheses first. And we're going to switch these around because I got the numbers backwards. And so in our formula, we have efficiency equals work output first. So output goes first, so 125, and then 375. Okay, that makes a little more sense. And then that number, we are multiplying times 100%. Okay, so you can go ahead and write that to solve your equation. So 125 joules divided by 375 joules. You're going to end up with a decimal, and then you multiply that times 100 to get your percentage. Okay? For number 3, what causes friction? So what are some of the factors that cause friction? If you go back, it said there are 2 main things that cause friction. 4, why are rollerblades not worn on an ice rink or ice skates on the sidewalk? So think of the surfaces that they go on. Why do you use wheels of a rollerblade on pavement and blades for ice skates on ice? Why do you use those? Number 5, how might oil increase the efficiency of a machine? I talked about this a little earlier. What do companies use oil in a machine for, and how does that make it more efficient? And number 6, what is the difference between ideal mechanical advantage, IMA, and actual mechanical advantage, AMA? So you can go back and read that. You do not have any labs today, so you're just answering these questions. Please make sure you're answering in complete sentences. And that's going to be the end of 4.2. And so next time we're going to be going on to 4.3, which is types of machines. So we're going to start talking about simple machines, and inclined planes is next. Simple machines as simple as a screw, a lever, pulley system, and so we're going to go through some of those really neat things we use every single day that make life so much easier. I'll see you next time.